Hello world, this is Craig. Okay, when we last left this 8010B, we were starting it up, and at the end of the last video we could see that we were getting sync pulses out of the 8010, which meant that it was going out onto the bus and it was reading something in, and we didn't have anything in the EEPROM, so it was just getting no ops or who knows what kind of random junk it was getting. So this is the next step. I put in a couple of known good RAM chips, so we know now we've got 1K of RAM on this, and I also put in my confidence test EEPROM, and I connected up my serial port. I checked, I make sure that on the COM I've got the right baud rate. The request to send is jumpered over to the clear to send, so that the 8251 which is underneath this test clip will in fact send out characters. And let's go ahead and power it up. So I power it up and do a reset, and let's see if we get a sign on. Nothing. Let's do another reset. 0. Several resets. We're not getting any serial out of this thing at all. Okay, well, all isn't lost because I have a diagnostic built into my confidence test. So let's close the terminal window here. So let's look at the pinout of the 8080. And something is really interesting here when we look at pin 16. Now the 8008 had an interrupt. The 8080 also had an interrupt, but now they added the enable interrupt and disable interrupt instructions. So the 8080 could turn that interrupt off and on. And for some reason, Intel decided to commit a pin, an output pin on the 80, an output pin on the 8080 to give us the status of the interrupt register or the interrupt latch inside the processor. So in other words, when we issue an EI instruction to enable the interrupts, pin 16 goes to logic 1. When we issue a DI instruction to disable the interrupts, pin 16 goes low. So that's interesting because internally we are either allowing or completely ignoring interrupts, and yet we have an output pin that we could connect to hardware that would also enable or shut off interrupts. And this is very rarely used. In fact, I have not seen in any Intel schematics, or in anybody's schematics for that matter, where pin 16 is used for anything other than just a simple indication. So if somebody has seen that in schematics, I would really like to see what they use that for. Okay, now there was one chip, the 8214, that uses this interrupt enabled input. But as you can see on the logic diagram for the 8214, here's the interrupt enabled input. And so that's simply gated to the D input or the final flip-flop. And then that comes out as the interrupt sign that then generally would connect to the 8080. This really only serves the function of stopping multiple interrupts from coming in, but if you've already issued a DI instruction after an interrupt has come, an interrupt's been received, then these additional interrupts coming in on the hardware aren't going to do anything. So even in the 8214, this interrupt enabled output has very limited use. But the fact of the matter is, of the 40 pins on the 8080, this is the only one that we have direct control over. We can issue a EI and a DI, and we can toggle this pin. So one of the things that I do in my confidence test is, as soon as I boot up, I toggle that pin to see what is going on. So let's look at the waveforms in the confidence test. Let me zoom in to a reset. Okay, so here's my reset. The line we're interested in is this one down here. We can see that this is our reset, and as soon as it resets, you can see my 5 toggles of the interrupt enabled output line. And so I have it 0 and I go high, low, and then I repeat that with a counter and a jump instruction 5 times. So that's why the timing looks a little funny. I go high, low, and then there's a period while it's doing the loop. And then high, low, and it repeats that 5 times. So what this tells me is that the instructions that the 8080 is getting off of the bus or out of this memory chip are valid instructions. It's doing exactly what I told it to do. The first thing I tell it to do after it comes out of a reset at instruction 00 is to start toggling this interrupt line 5 times. So since I see that in the waveforms, I know that this 8080 is reading valid instructions. Okay, the next thing that I do in my confidence test is when I configure the serial port, I toggle the DTR, the data terminal ready line, on the 8251. And so again, I do that 5 times. So that's just another example of the marker I put in. So as I configure the system, as it goes from stage to stage in the configuration, I have these little markers that I put in, and every time I do it 5 times, I toggle something. So in this case, I'm toggling the DTR. So normally it's logic low, and then it goes high, low, and then there's the loop, high, low, and then the loop again, and so I repeat that little loop 5 times. So what this tells me is not only is the 8080 getting instructions off the bus, we saw that it was doing the interrupt enabled output like we told it to, but this tells me that the confidence test was able to reset and now give commands to the 8251 USART. So I know in fact that I am talking to the 8251 USART. That gives me more confidence that there's nothing wrong with the board up to the 8251. I need to go fishing around and look at the signals between the 8251 and the output. Now I don't show it here, but I could drop a logic probe on the output and see if in fact I am getting anything, and that's probably what I'll do now is I will start looking at the output and seeing where I lose that signal for the sign-on. So let me go ahead and do that and report back. Well, fortunately that only took a little while to figure out. This wasn't a big deal at all. I probed the transmitted data coming out of the 8080, and I had a data stream there, but I didn't have it coming out the RS-232, and I looked and I actually had 3536 jumpered when I should have had 3435 jumpered. And so we can look here that what was happening was instead of coming out the RS-232 driver, it was coming out the teletype driver. And the way I missed that is you can see 3435 connects the transmit data to the RS-232 driver, 3536 connects it to the teletype, and when I was going through these, I just set them to the default value without really looking at them because generally that's what I want. So I had it set for 3435 jumpered, which was going to the teletype, and also the input was a 3839, which was on the teletype. So I wasn't getting input or output, so I had to change those both to the RS-232 driver. So I changed to 3435, and then on the receive I changed it to 4546. Okay, so now I bring up my terminal and we do a reset, and let's see, voila. Okay, so what this confidence test has done, and so we can see that it has the 3 and the 4 in the beginning with the question marks. That's where it's going out and is looking for the RAM. Is it finding the RAM at a prefix of 3, or is it finding the RAM at a prefix of 4? And this board, since it's jumpered for the 2732 EPROMs, which has 16K, its RAM is going to be up in the 4 prefix. So it says it found the top of the RAM at 4FFF, and of course the RAM then goes downwards from there, and that's the rest of the sign-on. So this confidence test, I have some various commands in here. I can do I/O commands for either group 1 or group 2. I can display memory, so I can do a dump, for example. So if I just do a dump, oops, have to be in uppercase, a dump to starting memory of 0000 and the ending memory of 0100. So I can do a memory dump. I can do all the typical things you would want to do for a confidence test. We can do RAM test. We can serial port interrupt test. Find out what version it is. We can do a reset. We can jump over into the toolbox ROM, but I don't have the toolbox installed right now, so I can't go to the toolbox. Basically, I have this confidence test split into two. This is the confidence test that I check a board and make sure everything is working okay. I also have a toolbox ROM, which gives me lots of little utilities that I have to just toggle address lines and so forth. And then I have more ROMs that are closer to monitors. Okay, so we've got this board up and going, and we're communicating with it. So that's 99% of the battle. Once we can do this, we can start probing around, having the confidence test do most of the work to check the inputs and outputs and memory and all of that stuff. So let's go ahead and have it start a RAM test, and it will just continue this forever and start exercising this board. Okay, well that's about it for bringing this board up. Might make some more videos discussing some of the programming the 8251 or the 8255 IOs. So we'll just see where the interest lies. Okay, so thanks for watching this series on the 8010B, the Intel single board computer. And as I mentioned, I'm a great fan of this. There's lots of fun to be had with just this 8010B, power supply, and a terminal. Okay, thanks for watching. And if you have anything to say, leave a comment below. Bye.